Hello, everybody. Hey, Tracy. I love seeing your smile. I love seeing everybody smile. I'm really excited to be here with you all. Thank you for joining today. I just want to congratulate all of you because I've been so impressed in the last few days with every single presentation. And I just wanted to say how amazing job you've done. So I want you to put your hand in the back, pat yourself in the back, but hold on, hold on. Use your other arm and give yourself a big hug because this has not been easy for anybody. And you have done such an amazing job. So I want you to know, you might think that you can do more, but you're doing fantastic job. Don't be so hard on yourself. And you are changing lives. So remember that you are changing lives and multiple lives, not just one. So, yay. Okay, so are you ready for this? I think so. I don't know. But some of you guys are used to my presentations. If you are not, get ready. So my name is Marile Colon Robles, and I'm the project scientist for NASA Globe Clouds at NASA Langley Research Center in Hampton, Virginia. And I am part of one of the best teams in this world in the science education team at NASA Langley with Tina Hart, Tina Rogerson, Jessica Taylor, Angie Reese, Elizabeth Joyner. And I'm going to talk to you about how we've been using your observations of clouds in research and all the exciting things I get to hear from your data stories when I talk to researchers. And so a little bit about me. I am from San Juan, Puerto Rico in the Caribbean, so I'm a Caribbean girl. This is why my name is in Spanish. Um, and I love reptiles, so that's why there's a picture of my favorite reptile, Komodo dragon, because it has the word dragon in the name. Yesterday was National Reptile Day, so we missed it by one day. I love music. I played multiple instruments, so that's a picture on the bottom of one of the music groups I was part of. That's Bomba en Plena, which is the music from the African slaves that were in the islands, and they used that as the newspaper of the day. And that's where salsa merengue come from. So really cool stuff. And I thought I wanted to be a vet. So because I love sharks, and that's my favorite shark right there in the bottom right, the whale shark. I really want to swim with them. It's fine because they're vegetarians. So I'll be okay that day that I do it. But when I started taking courses in University of Puerto Rico, I noticed that I was good in biology, but it wasn't like my passion. Like I was taking anatomy and physiology classes, and then yeah, I liked it, hated memorizing, but I was taking, or listen to this, organic chemistry, and I loved it. Yes, I know organic chemistry, it's crazy, but that's when I switched and I took a risk. So and I fell in love with chemistry. And in my last year of undergrad, I met this beautiful lady here, Dr. Olga Mayor Bracero. She's world-renowned organic chemist and analytical chemist, and she invited me into her lab. I was her third student, her first undergraduate student, and she gave me a project. I was the lead. I had to wake up in the 6 in the morning, change the filters, do it again at 6 p.m., burn all the filters, make sure they were clean, analyze all the filters I got, maintain the instrument because it was a new instrument. I was the only one that knew how to use it. Anyway, quite an awesome experience. And I learned about aerosols, and I really fell in love with this thing called atmospheric sciences. That was the first time I had heard about it. And I thought, let me take another huge risk now and go into grad school and learn about this. Now imagine the letter that this lady wrote for me as a recommendation letter. I never read it, but every single college I applied to said yes to me. So it was more of now where to go. And there's a guy called Ramanathan who's world known for cloud studies. And he wanted me because Ramanathan knew Olga, and he was going to send me to the Maldives, and it all sounded awesome. But then I met this beautiful face right here, Bob Robert, silly as can be, and I actually said no to Ramanathan. I still, to this day, I'm like, I'm probably the only person that said no. And I saw him like a year after that. He's like, I remember you. I'm like, I'm sure you do. I'm sure you do because I said no to you, but I don't regret it. I took a chance. Bob Robert gave me an opportunity and I got to see a field campaign in action. So at that point, he had gotten the largest NSF award for a research campaign. There were 4 airplanes, a radar, the NCAR radar was shipped to the Caribbean. People were calling the police on us because they thought the weather was changing because we were there present. It was awesome. And I got to be on a boat. I got to see a radar in action. I got to fly in the NCAR C-130 inside, outside, in the cockpit, everything. It was amazing. So I learned about clouds. So between the two of them, my head is always in the skies, okay? So just keep that in mind. In Puerto Rico, we also play volleyball. So I don't want to skip my volleyball team there. That's the NASA volleyball. That's my CALIPSO volleyball team. And I always use this picture for students saying that at NASA we work hard, we're very passionate about what we do, but we also love playing together. And there's different sports that you can play at the NASA centers. And it was in 2010 that I got the opportunity to come to NASA Langley here in Hampton, Virginia, and work in the Office of Education, now the Office of STEM Engagement. And I tell this to the students. The reason why I was hired, or one of the top reasons why I was hired, is because I knew how to read and write in Spanish. So my first project was interviewing Hispanic astronauts. That's right, I got to meet astronauts. It was amazing. Astronauts, engineers, scientists to do programs, videos, and activities for um, Hispanic students with Univision Communications. And since then, I've had a blast taking risks every so often. People giving me the opportunity of letting me try something new. And I'm so thankful to all these people. So NASA Globe Clouds, we have our own website on the Globe page where we describe a little bit more about the satellite data. So for every single cloud observation, how many? Every single cloud observation that you submit to Globe, we will try and match it to satellite data. And then you will get then a NASA personalized email with your observations compared to satellite data. So this is our main page. This is where we write blog posts, which we call the Cloud News. We have the new Science of Cloud videos, which would be really neat for you to use. It's NASA research scientists talking about how they study clouds in different areas of research. We have tips and tricks on how to make cloud observations. We have the new Clouds Family Guide and the new Student Project Support page. So just a few things from this page. And then you can contact us at any time. Satellite batches, we love satellites. Um, these are the satellites that we match to most often, or right now we're trying to grow that. We match to geostationary satellites. Here in the US, we match to GOES satellite. In Europe and North Africa would be to Meteosat, and to Asia, it would be to Himawari. And GOES in particular has data every 15 minutes, and we're working with the Meteosat core at NASA Langley for this. So when you're trying to plan your observations here in the US, you can go out at any time. And if the data comes down from the satellite and it's correct and there's no glitches or anything, you will probably get a geostationary match. Now for the other satellites, which are low Earth orbit or LEO, they go around the Earth. So about every 2 days, they'll see the entire Earth. So these are the ones that scan. These are the ones then that we suggest you use the date and time or the overpass times to figure out when to try and get that match. So right now, those are Aqua, Terra, and Calypso. Remember the Calypso team? Yeah. And so Calypso, we love it. Laser in space for 17 years. Anyway, this is the bread and butter. This is what we love to do. And we love to receive your cloud observations and see and compare them because satellites are great, but they're not perfect. So it's when we combine those 2 points of view, the satellite from the top looking down, and the observer from the bottom looking up, that we actually have a complete story. So the overpass times, remember, GOES or geostationary, you go out, you'll probably get a match. So they won't be here. But those lower Earth orbit satellites, then you can use either the Overpass time website or within the Globe Observer app. Okay, so how do you have to submit cloud observations to get a satellite match? Is there a particular way you have to submit them? No, you submit them to Globe. You can use the website, you can use the app, it doesn't matter, it'll get to us, okay? New resources, so let me highlight a little bit here. So we have the student project support page, and Angie spoke a little bit more about this early on in the week, but I wanted to take a little bit of time. What we've done here is write out some ideas that students can use to start up investigations using data already collected about clouds. So there's 4 different ideas, and it also includes air quality. Again, this is using data that has already been collected just to help out. You don't have to just stop at these ideas. These are, think of them as little starting points to generate more ideas. We also have the Science of Cloud videos. If you all participated of the 2020 Community Cloud Challenge, thank you so much for doing that this past summer. We had huge support from different NASA researchers. We had 8 different NASA researchers record and do videos for us talking about how they study clouds in their research. So we now have made all those videos available, as well as the awesome Globe educators and their step-by-step how to do a Globe activity related to clouds that goes perfectly with that research topic. Okay. Now this might look familiar if you were part of the 2020 Community Challenge, but look at it a little bit closer. The title is different. So we've remade it to be part of the the Clouds Family Guide, and we're calling it the Family Clouds Challenge. So now it's the choice chart, and it has all the videos, and it has all the activities, and we've added other ones like reading the Globe Elementary book about clouds and things like that. So just know that this is a new version of this that we started off with. So from the one that we made for the Summer Cloud Challenge, we've remade it for families, okay? If you've had trouble or like you've wanted help trying to figure out how do I read the satellite match table? Am I doing a good job? Am I matching the satellite? Why are the satellite observations and my observations not making sense some of the times? We've made a video for you about this. And it steps through each part of the table. So if you all remember 2 NARMs ago, and I kind of folded the match, I had a printed copy of the match table and we folded it, it kind of steps through that. But it also goes through the strengths of each point of view. The satellite has the strength of seeing the top of the clouds because it's looking from the top down, but it also has the strengths of seeing the higher level clouds. Our strength from the bottom up is seeing those low level clouds, okay? And then seeing some things that might be very thin for the satellite to certain satellite instruments to detect, or other mixtures like that, like obscurations and stuff like that. So it goes through the strengths of both views, because again, satellites are great, but they're not perfect. And so telling your data story, this is what we get to do in this team, and we're so blessed to do that. So thank you for the opportunity. When I go out and talk to researchers, these are the 3 main topics that they go ballistic over, like go, wow, okay? First is the amount of observations. So just the sheer number, the breadth, but also the depth, that there's in certain areas, there's multiple observations within the same or more or less the same area. And it would be great to have more of that spread wide. But also the location of these observations. Some of these observations are in areas that people or researchers have been wanting to study, but there's either not a lot of instrumentation, meteorological instrumentation out there, or they need it at a certain time, so you can't, it's really hard to move a calibrated instrument. And so the fact that people, we move, right? Um, it's really fun for them. And then the photographs. So whenever you can submit photographs with your observations of clouds, the sky, or obscurations, please do so, because it really helps, and especially in those moments when our point of view is the advantage, and we're trying to figure out um, how, why did the satellite do something or detect something, or the algorithm said it's this instead of that. The photographs are really the way to tell, oh, like it really puts us in your shoes, because then I can see what you were seeing. Data challenges, thank you so much for participating in the different data challenges. Tina Rogerson and I had no idea what we were getting into when we came up with the Spring Cloud Challenge. It was just an idea of, let's just get people motivated with this, and we'll do one every few months. And it turned into this huge thing because people love being part of a campaign. They love collecting observations for a cause, for a purpose. So what, if you notice, we've done a spring one, a fall one, and one in the summer, because the main idea was to get observations at different periods in different seasons of the year to then do detailed comparisons. And the data challenges help because they bring a lot of observations. There's like a peak of observations during these time periods. Even during the summer, we did see more observations than last year at this time. So they've worked out very well for that purpose. Now, because we're comparing satellite data, and researchers really like that, so it's really hard to find one data set that has multiple satellite data. So the data set that we have has the ground observations and all the satellite variables from all the different satellites that you match, because you could match to multiple satellites, not just one. We want to make sure that this happens correctly. And so we've been able to have interns, which is so great. Thank you, Tina Rogerson, the amazing Tina Rogerson, data manager. Without her, this would not happen. To have two fabulous interns so far. Third, we had another one this summer, um, but they were in high school. They came to us over the summer of their junior year. They were going into their senior year because they were good at computer science. Kevin Ivey, we miss him so much, but Kevin taught himself Python, which is amazing. But they both, Olivia was strong in MATLAB, Kevin Python. We worked with that, and they demonstrated how they can learn on their own, which is something, it's a technique that you have to bring into STEM, is wanting to learn and being okay with learning new things, and some things learning on your own and then reaching out for help. Why are these matches so important? I hear this a lot, and I think I went through a few ideas, but here is one of the observations we got last year. People, this was last year. It seems like ages ago, but this was just last year. This is a haboob, which is a dust storm. It's a word for dust storms in Australia. And the blue dot is the location of this observer in Australia. If you can see the whole cloud cover, okay, and his upward picture of all the clouds. And he used the app to take observations, which are a little bit higher than what we want for something like this, but you can still see that brownish color on the bottom of his pictures, which are indicative of that dust event. So without that ground observer, we would have had no idea that this dust storm was occurring at this time in this location. So that was huge for the researchers to find. So what have we done? The Eclipse is one of those examples where people go, are movable. And the North American Solar Eclipse, I was in South Carolina. I hope you guys were taking observations. Such an amazing event. Kudos to Kristen Weaver. where people took cloud and temperature observations before, during, and after the total eclipse. And you can see there that I drew that black line. That's the path of totality. So you would have seen a total solar eclipse if you were in that path. So that's where we brought in Dr. Brant Dotson into the team as our research scientist, and he took the data and he analyzed it or used statistical practices a little bit different than what he would do for just satellite data, but he got a really nice signal. And what he did is look at the temperature change when there's no clouds reported, few clouds, isolated, scattered, broken, and overcast. And that red line is kind of like the summary of what happened. So before, during, and after. And there was a 40% change he found, not we, he found, between no clouds and completely overcast skies. So this is huge. Um, People have tried to do this, but they were not as successful as we've been with this data. Also, Brand is now looking at the data from those data challenges and comparing them to satellite data. And this is in one of the Science of Clouds videos that you can watch him talk a little bit more about this in the Your Data and Research. And what he's finding is that overall, we are saying the same thing as the satellites are saying in total cloud cover, which is really neat and unique to find. And then if you notice on the left graph, um, you see there's 3 bars of one color. So the bar most to the left is low level clouds. The bar in the middle is mid level clouds. The bar on the right is high mid level clouds. And the colors just mean the different regions in the world. If you notice from ground observers, which is the left graph, you'll see those low level clouds reported the most, which is our strength and a point of view. The graph on the right is from the satellites, and you kind of see the opposite. You'll see per color, the right and the middle level graphs or bars higher than the low level clouds, which is their strength. Their strength is to see the higher clouds. So it's really neat to see this. He is really digging a little bit deeper into the levels, but this is, I think, one of the first times to see this. So it's really neat. Other ways that your data is being used is at NASA Goddard with the help of Dr. Nathan Arnold. We got another college intern now to compare GEOS model data. So GEOS is a weather and climate computer model that's used to simulate the atmosphere. And Dr. Arnold always thought that there was some sort of bias in the data being outputted with the model, but he didn't know of a good data set. He hadn't found a good data set to compare it to really nail down how much is that bias until he heard about globe and clouds. So Matthew just finished his second summer at Goddard. Um, and you can go to his poster and see his poster, but they've been able to calculate the bias on the clouds. So in certain areas, they overestimate the total cloud cover. And then what is the impact of that in energy balance, right? Energy coming in and energy coming out. So really neat stuff that we're finding with the clouds data. In our most recent paper that just came out in Bands, woohoo, thank you for all the co-authors and everybody that reviewed it. We noticed when we were digging through the Spring Cloud Challenge, so the paper talks about the Spring Cloud Challenge, how it was successful and what we found. We noticed that some observers were using the app in a really unique way. They were using, if you go to clouds, you can say there's no clouds. You can say, yes, there's clouds and contrails, or you can choose obscuration. Okay, so these people were choosing obscuration, boop, hitting dust, boop, and then taking their own photos. So these are some of those observations from huge dust storms that occurred in 2018 from Africa. And so what we thought, hey, this is a pretty neat method. Let's put it together. So we came up with the dust observations section in the Globe Clouds page because this attracted people around the world who are trying to look at areas that are now becoming drier and having new dust events. So think of like a dry riverbed or a farm that's now dried up. If a dust or a cold front passes, all that dust is carried up. So I know with you guys, or most of the time when I say dust storm, you think of the dust bowl, this huge ball, or maybe you think of the Mummy, the movie, or something like that. It doesn't have to be that big to be huge impact in the scientific community. So we've come up with these ideas. Daniel Tong is one of the researchers who are working really hard. He's interested in the Southwest US. So if you live in the Southwest US, take photographs because part of there's the valley fever, which travels with the dust, which is similar to meningitis in Africa. It travels with the dust. So they're looking at that. Whereas Kirsten Shapansky is looking more at high latitude or cold places like Alaska, Canada, Iceland, because there's more dust, it seems, Patagonia, more dust in the air that's occurring. But another way where you guys have come up with unique ways of submitting the data, and it's being recognized by the research community and making a huge impact. Another one, the Contrails report. For those of you that have done Contrails, thank you so much for doing that. Um, this is Dr. Caroline. This was last year. Today, last year, I was in Florida doing this Facebook Live. So if you guys saw that Facebook Live, we were at Montverde Academy in Florida, highlighting the school because they've done like 5,000 observations of these Contrail and airplane data. So what it is that they use an app. Let me go here. The Flight Radar 24, it's a free app, and there's other ones like it, where it tells you where non-military airplanes are at. And it has an augmented reality. I tell you, press that and it'll change your life forever. You'll put it up and it'll tell you exactly where the airplanes are at. And that's just a picture I took of a short-lived contrail in an airplane. And if you click on it, it tells you the airplane type, the registration, which is kind of like the license plate, and the altitude. And those three things are the biggest data points that people want to do. I connected a few weeks ago to Karen Long's class, and this is how it looks like right now. She has students in the classroom and virtually at the same time. And so, but they're still doing observations every single day of clouds and contrails. And this is why it's important because they might get activated. Why? Because this is a poster we had at AGU, American Geophysical Union, one of the largest, if not the largest research conference last year. And Dr. Helen Amos offered to stand by the poster for us. And she stood there for 3 hours straight, people waiting in line to talk to her because of, if you see the summary of observations down here, the summary, oh, right there, I found the laser. The summary of observations, these two graphs, nobody has that type of data. This data is altitude by number of contrails per contrail type. So they were going gaga over this. And so um, right here, Bill Smith is the researcher at Langley that came to me one day and said, hey, wouldn't it be cool if, and he taught me about flight radar 24 and all this stuff. I said, sure, let's do it. He has a computer model that him and his dad have been trying to test out that's to forecast the production of contrails, but there's no data out there to validate it until now that we have height altitude data through the Flight Radar 24. When they see the airplane, you can say the altitude, right? And we just submitted a proposal to use that data to validate the observations. This is why I told the Montverde students they might get activated because when, not if, when we get the proposal accepted, we'll need a lot of data. So if you want to be part of this project, let me know because I'll need a lot of sites. Brant wants to look at events when contrails are occurring and not occurring. Marit Sandest. She was one of the people waiting in line to see this poster, and she reached out to me in March. And again, we've been in contact a lot, and she wants to replicate it in Norway now. So she's working really hard to get that same information. And Dr. Rich Moore, he works with airplane engines and fuels. So he's really excited to get that registration number, the license plate of the airplanes, because that tells him how old the airplane is, the fuel type, all this stuff. So this is one of the most exciting right now project related to clouds that's going out. So let me know. Another thing, we've been working with other citizen science projects. One is the Polar Citizen Science Collective, where they take boats, ships to Antarctica through the Drake Passage, and they make observations from the boats. This is really unique because there's no data set out there really of having observations over the ocean. So the Drake Passage is the southern part of Argentina and Antarctica. And I've talked to CALIPSO researchers, and this is part of the slides I had in AGU a few years ago, but this looks like a cloud or something thick for Calypso right over the ocean. And I found this observation right next to it that had no clouds whatsoever, but it was hazy. And part of the theories is that it could be algae blooms or um, happening. So this is another way where your observations are having a huge impact, because when we looked at data, satellite data has this striation. I don't know if you can see it, but it has this natural striation. But you also see this layered structure. So something is happening there that Calypso can detect it slightly because it's laser, but we really need those eyes on the surface to see it. So how am I doing on time, Katie? Sorry.
On my mute. So we are at 10 o'clock.
Time. Okay.
So yeah, if you wanna go.
So I hope this has inspired you. If anything, please contact me if you have any questions, but please remember there's these awesome resources, and a lot of the resources are in Spanish. So I hope this has been helpful, and thank you so much for joining.